All right. Hey, good morning. How many are happy to be up this morning? Okay, that one guy. Woo! All right, it's 8:30. It's day 3. Are you excited? All right, good. All right. My name is Eric Johnson, and I've been joined by Sanya Gita and Ben. They're from a little startup we like to call Salesforce. And we're going to be telling you our story about CI/CD. I'm really glad you're here. A little bit, let me flip this. Let me grab the clicker here. We're going to be talking about, obviously, CI/CD this morning. I'm going to go back here. There we go. All right, there. Now we got some names. Now I'm set to go. So it's 8:30. I know we're kind of sleepy, but I'm glad you're here. And we're kind of going to get started here. But before we get started, I'm going to give you a couple of rules while I'm talking, okay? Now, you may be looking at me going, who are you to make the rules? I've got the loud mic. So they're not actually rules. They're more guidelines, but they're going to help you out, okay? The first rule is this. This is any number I want it to be, okay? It's okay to laugh. Some people are like, does he know he have one finger? Yeah, I know. I did not just wake up like this for the first time this morning. If I did, I would not be here with you. Okay, I love you, but not that much. I'd be somewhere coping, okay? The second rule is these are quotes, not apostrophes. Okay, I do this a lot when I'm speaking. The other day I was working, okay? So I do this now, and what happens is someone who doesn't know the rules, they'll think I'm waving at them. Is he waving at us? I'm not waving at you unless I am, okay? And it's contextual, and you kind of have to figure it out. The last rule is these are thumbs. My actual college ID was... I actually raised my foot. You can't see in the picture, but so I do this a lot. Hey, how's it going? Or thumbs up or something like this. And when I do that, people think I'm just pointing at myself, which I'm not, unless, of course, I am. So, again, contextual. So I do make a lot of one-finger jokes. I'm comfortable with it. I like to have fun. If that makes you uncomfortable, I'm also comfortable with that. So either way, I'm good to go. So... I am glad you're here. We're talking about CID for serverless applications. I want to kind of level set for you. This is a 300 level, so we're going to be getting a little bit into how we do CI/CD on AWS. What are some examples? What are some things we use for CI/CD? And then Salesforce is going to be telling their story on their CI/CD. And so we're going to kind of define it this morning to make sure we understand it. And then afterwards, we're glad to answer some questions. We'll be hanging out a little bit. We can answer some questions. So let's jump in and get started. So if you put, I don't know how many people we have in here, several hundred. You put several hundred people in a room and you say, what is CI/CD? You'll probably get several hundred responses. Okay? Sometimes we have a hard time defining, here's exactly what it is, here's what we mean by that. So I'm going to kind of set that up for what we're going to be talking about today when we talk about CI/CD. So when we say CI/CD, we can mean CI, which is continuous integration. We can mean CD, which is continuous delivery. Or we can mean CD, which is continuous deployment. Okay, and so let's break down kind of what that looks like. So first of all, we kind of have this pipeline idea. Now let me ask you a question. How many of y'all have a CI/CD now? Excellent, that makes me very happy, okay? How many are looking to improve your CI/CD? Okay, good, that makes sense that you're here. You're like, nah, we love it. I don't even know why I'm here. So I'm glad you're here. I'm glad we can help you. I'm glad we can kind of help you get some advantage on this. And another thing to understand, obviously, this is a serverless track because we're going to be talking about CI/CD for serverless. How many of y'all are using serverless? Excellent. Okay, very cool. All right, so when we look at a pipeline, and this really doesn't matter if you're doing serverless, if you're doing server full or whatever you're doing, this is pretty much the same. So you pretty much have several stages. You've got the first, which is your source control. This is where our developers commit their code, and they do merges, tests, PRs, all those kind of things. Okay? The second part is where we use our build step. This is where we're going to build it out, do unit testing, things like that. The third thing is our staging, or you can call it anything you want: beta, alpha, gamma, Bob, Sue, however you want to do that, right? So this is when we push out code so that it can be tested with eyes on screen. And finally, we push it out to production. Now let's talk a little bit about why a CI/CD. Now, most of your hands were raised, and that makes me excited, okay? But I kind of want to explain why a CI/CD is so important, okay? And you're probably like, look, I already know that, but I want to point out a couple things. First of all, the automation part, right? Okay, so when we do automation, we're going to talk about the stages of automation in just a minute. The automation is critical because we like to know that when we do it one time or we do it 50 times, it's the same each time, right? And anytime you introduce manual interaction to that, it's not the same each time. I love it as a solutions architect before I actually came on as a developer advocate for AWS. I would sit with companies, and my job was to help them do AWS better. And a lot of times we would talk through their architectures, lift and shift and migration and all those kind of things. And then I would sit down and I would say, all right, tell me about your CI/CD story, okay? And there were several responses. A lot of times it was like, what? Sysid? What are you talking about? So we walked, okay, what is CI/CD? We talked through that. Then a lot of times you go, oh yeah, it's sound, it's perfect. Our CI/CD is rocking. All right, okay, tell me about it. Is it automated? Absolutely automated. It's beautiful. It's a thing of beauty. All right, tell me about it. Okay, so here's the deal. Bob compiles it on his computer. Okay, right there, I'm like, oh. Then he zips it up on a zip drive. That's old school right there. On a USB thumb drive. I don't use thumb drives for obvious reasons, but you'll get that. Why doesn't he use them? All right, so anyway, and then we pass it over, and Susie checks it on her computer, and then she takes it and she passes it over to Stan, and Stan pushes it out to production. Here's a little tip, little secret, okay? Close the doors, we don't want people to hear this, all right? If your CI/CD includes somebody's name, it's not automated. There you go, you may leave. That's the thing, and I hear that a lot, okay? So think about that on your automation story. Is it truly automated? So let's look and see where things can do. Well, actually, let me talk about this. The second reason that a CI/CD is so critical, obviously for where we can depend on it being the same each time through automation. The second thing is we want to make sure that the business is aware of what we're doing. Okay, so if you're not a developer in here and you're part of the business, the stakeholders, you're probably saying, yeah, we want to know. I've been the developer where they come to me and say, this is what we want to build. This is our baby. This is our dream. Here's the colors. Here's the lights, everything. And I go, okay, got it. And I go away for 4 or 5 months, and I come back and go, here you go. Here's what you asked for. And I bring it up, and I show them all the bells and lights and all the things, and they say, that's not even close to what we asked for. Okay, ever been there? Yeah, that's a tough place to be on both sides. We paid you a lot of money, and this isn't what we asked for. With the CI/CD process, especially on that third thing, when you're pushing code where the business can see it constantly, they're able to put the brakes on very early. Go, no, that's not what we asked for. Okay, so that's a real critical thing. So we want to be able to, when I have developers that work for me, I tell them, look, I want you to commit every day, work in very small chunks, commit your code. We want to see that. We should be building 4, 5, 20, 300 times a day, okay? We should be constantly building. Now let's look at how we kind of do that. When we break this down, CI/CD or the other CD, this is what it looks like. So first of all, we have continuous integration, and this is kind of the same anywhere you do this, right? So our developers commit their code, and then it's an automated merge and test on the build. So we run our build tests and we do unit tests and compilations and whatever we need to do, okay? Then when we move to continuous delivery, this is what this looks like. The second step is also automated, okay? So we'll actually push it out to our staging, but we do not automate the delivery out to our production. And that's okay. Right? A lot of companies are like, look, we trust our our tests, our coverage, but we also want to look at it and have somebody do it. And a lot of developers, from a developer angle, like, look, I want somebody else to push the button. I don't want it to come back to me. I want them to go, yes, I approve, right? Because I want to be able to say, worked on my desk, right? So that's what you're able to do. Okay, so that's continuous delivery. Continuous deployment, however, is a fully automated system, right? So you are automated source control, automated build, automated deployment to staging, all your tests happen, then you have an automated deploy to production. And that's the story these guys are going to tell here. That's what they've got set up. It's very cool. And that's something that Amazon does and AWS does as well. We have massive amounts of automation that test and cover everything we push out, and we deploy millions of times in a minute. That's not true. Those aren't real stats. But we deploy a lot each day. Okay, that's a high number, a lot. Excuse me, one moment, please. All right. So, critical to building a CI/CD pipeline are the right tools. And the same with serverless. When we're building a CI/CD pipeline for serverless, it doesn't look terribly different from a normal CI/CD pipeline. I say normal, from the other CI/CD pipelines. But it is a little different. I'm going to walk you through that. So the first tool I want to introduce you to is the right tool slide, and then SAM. How many of y'all use SAM now? Excellent. Okay. Not enough of you, but okay. All right. Okay. The rest of you, listen up. This is good stuff. Okay. SAM is the serverless application model. And it's designed, it's built on top of CloudFormation. So if you've used, how many of y'all use CloudFormation? All right, a good number of you. If you use CloudFormation, the jump to SAM is very easy because they're really kind of interchangeable. SAM, what we did is we said we're gonna build a CloudFormation that has specific serverless resources, functions, APIs, simple tables, which are DynamoDB tables, different things like that, okay? And what we want to do is, if in CloudFormation, if I create a Lambda, the code can look very long. In SAM, it's very short because we make some assumptions for you, and we do some automation for you, and I'll show you that. Now, with SAM, you can mix in traditional AWS CloudFormation resources. So you can use these special serverless resources, but you can also say, hey, we're going to do S3, Kinesis, CloudFormation, or I'm sorry, step functions, things like that. It supports use of parameters, mappings, and outputs. So if you're CloudFormation, you understand those are dynamic ways of passing data around. So you can templatize these and move them around. And then you can do intrinsic functions like ref, sub. These are referencing, again, dynamic data. You can also use import value, which pulls from other data. Now, the interesting thing here is you cannot do it for a REST API ID. So if you're building a REST API and you're building out the functions that live with it, they have to be in the same folder. And then it uses YAML or JSON. So let's just get this out of the way real quick. Who are my JSON users? All right. That's all I care about. No, that's not true. Who are my YAML users? Okay, that's what I'm talking about. I'm the YAML guy too. I love YAML. I love the joke. YAML, my other data center is a YAML. I don't know, I like it. All right, so this is what SAM looks like, okay? It allows you to take these 20 lines, roughly. I haven't counted them, but I think there's 20 there. But like I said, it's any number I want it to be, right? So these one line, and you can create 4 things with this, okay? With these, I'm creating the Lambda function, the first arrow. And I'm adding a role, and that's part of the function. That's inherent to the function, so I'm attaching it to the function, okay? And then I'm attaching an event. Now, if you're dealing with serverless, we know that every Lambda needs an event. That's why we call it event-driven architecture, right? So an event happens, it triggers this Lambda. So I'm going to take and I'm going to attach an event. This one's going to be an API. And SAM is smart enough to say, hey, you want an API? No problem. I'll build you an API through API Gateway. I'll make the path be products/product ID, where you can pass a parameter, and I'll make it so that it only handles the get method. And of course, I can change this. I can add some CORS settings. I can add some other things. I can add authorization, all kinds of things. And then the last arrow is our table. Okay, and this is a serverless simple table. And literally those 2 lines right there will create a DynamoDB table with a hash or key, if you're not familiar with DynamoDB, of ID. And it's going to be dynamic capacity, so it's just going to grow and shrink as you need. And it's going to be encryption at rest, encryption in transit. You have a fully functioning DynamoDB table. So DynamoDB, if you're not familiar with DynamoDB, I really suggest you look at like a Rick Houlihan video on YouTube. Very powerful database. It's used to power things like, Cyber Monday, Black Friday. It's a big thing that Amazon uses for fast input-output type stuff. All right, so you take these 20 lines and you get this. Okay, simple architecture, Amazon API Gateway, Lambda function, all the roles for them to talk. Okay? Now notice, and I want you to look at on that policies line where it says DynamoDB, I'm doing very granular permissions. I'm saying he can read from that table. And so what I've done is I've set up a permissions here that said only this function can read from only that table. It can't write to it. It can't do anything else. It can only read. Okay? So that's very granular permissions right off the bat. Okay, so SAM is a tool that you're going to use for local development, and you're going to use SAM templates for your CI/CD, and that's going to be the infrastructure as code that's used when you deploy your application. It's going to handle your infrastructure, and it's going to handle your code. All right. So the second thing you want to look at is your code repository. What are you doing for your code repository? Okay, how many of y'all, is there anybody in here, and you don't have to raise your hand, but are you not, that's a weird, how many of y'all are using code repository right now? Some type of code repository. All right, okay, I see several not raising their hands, and that's, I get that. Okay, I've been with that company too. Man, if you're not using a code repository, and you don't have to use ours, the one we have inside is Code Commit. It is a Git based repository. It's very powerful. It allows you to, one of the reasons I would suggest Code Commit is if you are needing very strong security. If you want to use the IAM wrapped around this, you need to really lock down this code. Obviously, GitHub has very strong security as well, but this is going to be in your account using AWS securities. But you can also use GitHub, GitLab, all kinds of different ones. Now, we have some compatibility with those as well when you're using some of our other CI/CD tools, which we'll talk about. But something to know here is GitHub is compatible both with code build and code pipeline. So you can trigger builds from GitHub. You can trigger code pipeline from GitHub. And then Bitbucket integrates with code build, as last I knew. So I haven't seen any changes on that. You can run GitLab. It doesn't integrate directly, but you can build some triggers if you need to. You can build some hooks or your own private repo. So bottom line is, these are all Git-based. We've seen people use, SVN. We've seen, different things like that. Git is pretty much the standard, though. And Code Commit is just that. It is a Git repo that is managed inside of AWS, and you have a lot of control there and a lot of power. All right, so the next one I want to introduce you to is the code pipeline. Anybody using code pipeline right now? All right, some of you. Good, all right. Code pipeline is the orchestration tool. It's kind of this is really critical when you're building a CI/CD or you want to modify or make your CI/CD work really well. I would heavily encourage you to look at code pipeline. And here's why. Code pipeline is the guy who says, or is the tool who says, hey, if someone committed here, I'm going to take that artifact and I'm going to pass it here. And he orchestrates, and you can build these pipelines using code pipeline. All right? You can model and visualize your software release process. You can build, test, and deploy your code using the different tools. And then it'll integrate with third parties. And that's an important thing, because you may say, you know what, we like Jenkins. That's fine. We like Jenkins too. So you can integrate with Code Pipeline with Jenkins or Hudson or TeamCity, or there's all kinds of partners that have plugins with Code Pipeline that you can use. Code Pipeline is just the orchestrator that says, okay, you got that, you got that, you got that, let's pass it around. Okay, so let's look at what that might look like, okay? So this is a code pipeline of basically a minimal developer's pipeline, okay? And so what this does is this builds out, it's 3 stages. It builds a code artifact, it has one development environment, and it uses AWS SAM and AWS CloudFormation to deploy the artifact. And you can see how this works in that it basically you have we're actually using Code Commit in this example, and it'll tell you what tool you're using. They check it into Code Commit. Then it uses Code Build to build out the stuff. And we'll talk about that in a few minutes on how Code Build works. And then it pushes out to deploy. Now this is kind of interesting in that when we deploy with CloudFormation, it creates a change set. It evaluates the change set against what you already have out there, if you're already out there. And then it says, look, if you didn't change anything, let's not do a deploy. Or, okay, I'm going to make this deployment for you. And it tries to do some syntax and linting against that to make sure it looks right. If all is well, then it executes a change set. But you'll notice there's a third step in this deployment down here, okay? So you have these different stages, and each of them can have steps. And the third step is called the run stubs. Now, it's just called that because that's whoever built this pipeline named it that. You have some flexibility. But notice the source that it's using, or the tool it's using. It's using a Lambda. And what this does is once I deploy it out to my development environment, it's going to actually use a Lambda to test that development environment, run some automated scripts against it. Am I getting the right text coming back? Am I getting a 200? Is this failing when it should? Is this working when it should? All from a Lambda, okay? And then if the Lambda says everything's good, then the deployment worked. If it doesn't, then it didn't work, okay? And you can do some rollback, different things like that, okay? So Lambda, if you don't use a lot of Lambda, it's good to understand Lambda is really kind of the Swiss Army knife of AWS. You can do a lot of things with Lambda. All right, so let's take this and go out a little bit. Let's make this a little more advanced. This is what you might use in like a production environment, okay? So this looks similar, okay? We have our source, our build, and our deploy testing, just like we did on the previous one. But now, we can continue this process, either automated or manual, but we continue this process and we pass the artifacts into the deploy staging, okay? And the deploy staging then creates a change set, and at the time we create change sets, we can use, there's different ways, and when we talk about best practices, I'll explain this, but there's different ways we could say, use these parameters for development, use these parameters for staging, but it's the same template going through, right? So then what happens is in the deploy staging, it does the create change set, execute change set. Then it runs an API test, okay? Because we want to know what load looks like. We want to know how it's going to handle a lot of things. And we use a partner called RunScope for that. It's just an example. You can use a lot of different ones. And then finally it comes to that QA sign-off, okay? And this is the continuous delivery option. What this does is you put this right in code pipeline and you can say, I want you, when you hit this point, I want you to send an email or an SMS or to some type of message out. And there's all kinds of options you can do that, to a group, a person, whatever, and I want them to approve this. And they'll actually get an email that said, hey, this has been deployed. Go look at it here. Here's a link. And they can go and they can look at it. Okay, great. And then they have an accept or a reject. Accept, then it continues, and it goes out to production. Reject, and it gets kicked to the curb. Right? So you have this power for someone to say, I want Bob to approve it. I want Susie to approve it. I want somebody to approve it other than I. And as a developer, I want that. I want business to approve it. I want the stakeholders to understand what's going on. Right? And then finally it goes out to deployment. And you can see here where we've got the create change set, the execute change set, and then we're going to do the post-deploy stack where we can do testing again with Lambda. And we have some easy ways of setting that up, which I can show you. All right, something to understand, though, is one of the best practices that we encourage, and there are some reasons you may or may not do this, which these guys might touch on, but we really heavily encourage that each environment or each stage be in a separate account. Now, what we say is if you have each developer should have their own account, each staging should have its own account, production should be its own account. Number one, that's for a security reason, okay? Limit the blast radius. Only 3 people should be able to, all right, I'm picking random numbers here, but minimal people should have access to your production environment, okay? And the first way to do that is just buy an account. Rather than having to build out all the IAM, just have a separate account for it, and only these people have access to it, right? The second thing is cost-wise. When we're running serverless applications, for the most part, unless we start bringing in server-full stuff, it doesn't matter where it's invoked. If I invoke it 17 times in one account, it's going to cost the same as one time and need 17 accounts, right? Because that's the way serverless works. But here's the fun part. The way we price serverless for Lambda, so let's say, you get 1 million invokes a month for free and 400,000 gigabyte of memory for free. And if I put that all into one account, all my accounts are going to share that. If I put it into 17 accounts, I get 17 million invokes per month. Okay, work the system. I'm going to need you to edit that. Okay, y'all are going to keep my secret, right? All right, yeah, work the system. Use it, all right? All right, so that's an example of how the pipelines work. So next thing we're going to look at is code build. Anybody use code build now? All right, code build came out 2 years ago. Yes, 2 years ago. Maybe 3. And it was, to me, the final missing piece that we really needed. I consider code build, I kind of call it the command line as a service, okay? The way code build works is you're going to have a build spec file that looks something like this. This is just an example. You can do a lot of different things, okay? Might look different for different languages that you're using, right? And so the idea here is it has multiple phases, okay? You can pass in parameters, and you have phases, and you can say at install do this, at pre-build do this, at build do this, at post-build do this. And how it works is it's going to spin up a container, either one of the supported flavors that we put out, or you can create your own, and it's going to run these commands, and it's going to go away. That's all it does. So the idea is if you can do it in a command line on your system, you can do it here in code build, right? Very powerful. And one of the things I've seen people do, man, I've seen them call out to APIs to verify things. I've even seen folks do a deploy from the post build. Rather than pushing the artifacts back to code pipeline for CloudFormation, this is the way I've seen the serverless framework. Now, I think you can actually go to CloudFormation now, but way back, I couldn't, and so I would use the post-build area and just do SLS deploy, okay? Now, I'm a SAM guy, and we're not competitors, but same. I'm SAM, and there's serverless framework, but both of them you could actually deploy from here if you wanted. Now, I encourage you to move it out to CloudFormation because you get more eyes on what's happening and it's staged out a little better like we showed in the pipeline. But again, if you can do it in a command line, you can do it in code build. All right? All right, so the last thing we have is AWS CloudFormation. And most of you are pretty familiar with CloudFormation. I think we had a lot of folks raise their hand. But if you're not, CloudFormation is the central form of infrastructure as code on AWS. Okay, there's different ways. We have SAM that sits on top of it. We have the CDK. Anybody use the CDK yet? Okay, a couple of y'all. CDK is much more programmatic, right? This is declarative, so you can do a lot here. But CloudFormation is very powerful, and you can do a lot with it. Okay, and again, SAM is built on top of that. All right, so let's talk about testing. Testing is a good idea, right? Yeah. There you go. All right, so one of the cool things when you're dealing with serverless is how and where do we test, okay? So let's take a look at our pipeline again. We have our source control, our build, our staging, and our production, okay? And the very common place, obviously, is we test at the build stage, right? Now, one of the cool things about code pipeline is I don't have to do my configuration, test, and package all in the same stage. I could actually do just my configurations, pass it back to code pipeline, and then I might have another use of code, still using code build to do my tests. Probably don't need to, but if you'd like to be that granular, you can. But the fun thing about serverless is you don't have to just test here, you can test all along the pipeline. Okay? So let's talk about that. So if I'm doing all along the pipeline, there's multiple things I can do to build it out. So let's look at a pipeline again. So here's our pipeline, our source control, right? So obviously, I really heavily suggest you start a PR process. And that's a peer review process, right? So instead of just everybody checking into the same repo, set up a peer review. And GitHub does it great. Code Commit does it, where you can actually say, all right, I've got this. I've forked it out. Here's the changes I've made. I want somebody to look at it, and then we'll merge it back in. Okay? There's a process that says, I want to have other developers look at this. Okay? And if you haven't seen it, we just released a new service that does some code analysis as well. And so you might look at tapping into that as well. I know I'm gonna. So I'm gonna roll that in as my process. But that would more happen at the second stage, which is the build, right? And this is kind of the commonplace when we showed in the last graph. It's kind of commonplace that happens. But here's where you can run your unit tests, you can lint, and then you want to make sure your code successfully compiles. That's always a good mark. Hey, it compiled, right? If it didn't compile, we're in trouble, right? So then in our deployment, we check, did it deploy successfully? And that's where we can automate Lambdas to check that. That's where we can put eyes on screen to check that. You can do your mocked or stubbed integration tests, all kinds of things. All right, so then we take it out further in the pipeline. What do we test next? Well, in the deploy staging area, it's gone out to staging. We have our application. We want to make sure our application deploys successfully. And this, again, like I said earlier, is where the business gets a look at it. Eyes on screen, right? Does this look right? Does it read right? All those kinds of things. We test against real services, potentially against production dependencies, okay? Because in serverless, it's very easy. Man, and you all know this, if you've been developing longer than a couple of years, you've probably been there where it's like, all right, everything works on my desktop, and everything works on staging. And then when we push to production, it's like, yeah, we don't have that patched out. There's not enough memory. Or production doesn't look anything like staging, you know? In staging, we use Windows. On production, it's all Linux. I don't know what happened. It's like, dude, what? So the beauty of serverless is I can build matching environments very easy, very cheap. So maybe not a development if you want to save some there, but at least in your staging and production environments, match those up, right? So that I can say, worked on my desk, worked in staging, works in production, right? Okay, and finally, again, in the deploy to prod, and you can do this in staging as well, but deploy to prod, we can do pre-traffic Lambda tests. You can do canary deploys. You can make sure those complete, you know, and wait, or you wait successfully, make sure they complete, and then you want to make sure they're deployed 100%, and then you can do your post-traffic Lambda tests. Let me explain that, okay? You might be, what? One of the things we have in Lambda and service is what we call safe deployments, okay? So let's go back to our SAM template. And this actually wasn't in the SAM template that I showed earlier, but this is an example of how to set it up. Now this is a function. Excuse me. That's the mic right there. And on this function, we have some things that handle safe deploy. So let's kind of focus in on those. So first thing we're going to do is we're going to declare an alias. And all this does is this auto-publishes an alias, and we just say, auto-publish an alias for the environment, okay? And then we have our deployment preferences. The first thing we declare is a type. And I'll talk about the different types in a moment, but this one we've chosen linear. And this is gonna deploy 10% every 10 minutes, okay? And what that means, it's not like, okay, let's be clear, and you probably get this, but just to be clear, it's not 10% of your code. All right, we put out the first 7 lines. It doesn't seem to be working, okay? It's 10% of your traffic, okay? So we're gonna route 10% of your traffic every 10 minutes, okay? And then we have a list of alarms. You can do up to 10 alarms, okay? These alarms are critical because if they hit metrics, if they're alarming, you want the deploy to stop and roll back, okay? So then you have hooks, okay? You have a pre-traffic hook and a post-traffic hook, okay? And the pre-traffic hook they're both lambdas. They point to specific lambdas. And they could be the same lambda. You might do the same thing on both sides, or you might do that. And the lambda's specific job is you have test logic in there, okay? Now, let's look at the type of deploys you can do, okay? There's 3 types you can do. You can do canary, linear, and all-in-one. Now, canary, if you're familiar with the old stories from the coal mines, I'm almost old enough to be there, you know. The coal mines where they would take a canary in. If the canary died, get out. Okay, that's a bad thing. Same thing here. If the canary dies, get out. Roll it back. Okay, that's how it works. And you can set these custom. Hey, 10%, 5 minutes, 10%, 10 minutes, however you want to do it. The second thing is the linear, which we just talked about. The linear says, do this much traffic for this long and continue to roll it out. And that's a good way if you're checking load as well, okay? Hey, if I'm dealing with some now Lambda's gonna scale for you, but you might have some downstream services that aren't scaling, that don't scale as well. So this linear is a good way to go, okay, yeah, that's not working, back it off, okay? Finally, you can do the all at once. And the all at once is the standard. If you deploy and you don't have any kind of canary or any kind of safe deploy setup, it's gonna go all at once. Boom, you're there. Hope it worked. Right? And that's always fun. And do it on a Friday night. Just before you go. Hit it, walk out the door. That's confidence. That's how I do it. All right, so how do these pre and post hooks work? So what you've got here is the way we do is we start your deploy, and then we create an alias, that auto alias that we talked about. We create an alias, we put the new code there, and then we trigger your pre-hook Lambda. We say, all right, here's where it is, test it. And so your Lambda goes, test it, does its thing, okay? All right, and if it comes back with a 200, yep, we test, okay? Then I'm gonna say, all right, then allow traffic, okay? And this is gonna build out, and so depending on if you did canary or whatever, we're gonna do all the traffic. As soon as all the traffic gets out, depending on which version you did, then it's gonna run the after allow traffic. okay? It's going to call that hook and say, hey, we still working? Good, that's good. We're still working, all right? So, and then it's going to end it, and you're good to go, okay? And that's per Lambda, okay? All right, so let's talk through some best practices. With AWS SAM, there's a couple things that I'd like to tell you, okay? A lot of times I get questions on how do I break it. So we're dealing with microservice applications, right? Hopefully you're not building monolithic applications in Lambda, okay? You can do it, but it's not the best practice, right? So we're dealing with microservice applications, and one of the questions I get is, how do I break them down? What's an application? What's a sub-application? How many things do I put in a repo? How do I break down the repos? Okay, so one of the things we do, and actually you get the second point there, less dependent Lambda functions share event sources, split them into their own code repositories. That's kind of one of our practices. So let's kind of talk about that. If I've got an API, and that API triggers 9 Lambdas, that's an application, right? Okay. Now, it might be a small part of a bigger application, but in itself, it's an application. Okay, so I'm going to put those, there it is, there's a repo, there it is. Now, I may have a repo that holds multiple points of these applications, and these guys do that, and there's a good reason for it. Okay, they've got a great story on how they're doing a mono repo with a microservices app. That's perfectly acceptable, and there's long debates on Twitter going on about that, and you're welcome to chime in, but I'd rather just code, right? But we suggest that if you can split them out, it's just a management thing. The best thing to do is to evaluate what works for your team. What keeps us organized without getting so far into management we're not getting the code done, okay? All right, so the first point is unless function handlers share code, split them into their own dependent Lambda functions. This is the idea of single responsibility, right? A Lambda should do one thing, it should do that one thing really well, and that's it. And it shouldn't, generally we don't call another Lambda from a Lambda, right? We'll use asynchronous things like SQS, SNS, Event Bridge, streaming, different things like that to trigger Lambdas. Okay, so that's another way we do best practices. Finally, when you're looking at testing, locally lint and validate your YAML and JSON, and then do it before you commit, and then do it again in your CI/CD process. It doesn't hurt to do it again. For one, if you're working with 30 developers and you know you lint, you don't know everybody else does. Okay, so put it in your CI/CD process for testing. Second thing, okay, in SAM, take advantage of all the things SAM has to offer. Take advantage of the parameters and mappings. Reuse a template. One template should build out your entire architecture. You might use multiple templates, but all architecture should be built from the same templates. Don't build one for production, one for development, one for staging. I guarantee you they will divert. Okay, and then you're back to, these environments aren't the same. Okay, use one template or one set of templates to build your environments, okay? Use the global section. If you're not familiar with the global section, we offer a section that says whatever you put in here will apply under functions, will apply to all functions. Whatever you put under API gateway will apply to all API gateways, okay? Use export and import value. If you do need to do multiple templates, like I was talking about, pass values between them, right? And build out multiple environments, such as for development, test, production, even DR, using the same template, which I just said, but do it across accounts. Work the system. But don't tell them I said that. Okay, so this is what that environment looks like. Now this is kind of a dream world. Hey, we're all serverless. There's no, but so I'm going to build it across. Now, you do have to answer the question of what if our serverless talks to relational database, which is not serverless. Did you all see the new relational database service that we have for Lambda? If you're doing serverless, we now have an API management out that will allow you to, it will manage your API connections to manage your database connections to relational databases. So relational database is still a thing. We're going to be doing a lot of that, and you can do it in serverless. But you probably don't want to spin up RDS or Aurora in every single developer's account. So that's one of those occurrences where you might do a shared account for that. That's what you guys do, right? Yeah, that's one of those occurrences to save money where we're going to do a shared account. However, in your staging and production, I encourage you to separate those and have them be so that they match, they replicate. Secrets. I talked about this earlier. I said I would talk about this. Secrets are things we don't want people to know. Okay? It's a shh, don't tell. And where do we store those? Okay, there's several options we can do this. Okay, one is AWS SAM parameters. Just like CloudFormation, I can have an area in my SAM and I can say, here's parameters that I want to be passed in. Here's an API key. Here's a password. Here's a string. Here's the environment name. Whatever you want to do. Okay, and I can pass those in. And so I can do that when I create the functions. I can pass those in, and it's you can have default values. You can data type them. You can override them on deployment, that kind of thing. This is good for environmental settings that if someone were to see, it's all right. It's not where I would keep API keys or passwords or different things like that, okay? The second thing you can do is stage variables. If you're managing, for some reason, you're managing multiple versions of stages on API Gateway, and if that doesn't make sense, that's okay. On API Gateway, I can have a V1, a V2, something like that. You can pass variables to the resources behind it. So I can say, if they hit V1 on my API Gateway, I'm going to pass a variable to the Lambda behind it saying they hit V1 or do this value. Okay, that works. It's a little complex. I'd say that's more of an edge case. Sometimes we have to do it, but that's available to you. The best practice that we suggest is the parameter store. The parameter store is part of the SSM or the EC2 SSM management system, and it's just that. You can have encrypted data. It's accessible through AWS SAM at deployment time. You can access it from the code. It supports encrypted values, and it's account specific. So here's how that looks. Let's say I have a development environment, and we've got an API key that's for my development. I'm going to put that in the parameter store. I'm going to encrypt it. And then when I deploy my Lambda, it's going to grab that and put it as an environment variable. Okay? But it's going to be encrypted on the dashboard, so if someone else were to be in my account, they can't see it. All right? That value is not the same for everybody, but it's the same parameter key name. So it's like, API key. That's our parameter key. So it's developer number 2, same key, different value, but it's going to use the same logic to grab it, so the template doesn't change. In production, API keys, same key, different value. Again, you see how it depends on the account it's in. Another reason to split your environments into accounts, all right? The other way you can do it is you can actually, during your code, you can grab that, okay? Now, here's the pros and cons, right? If I do it at startup or at creation or update, then there's no latency to make that call. Latency is very little, probably negligible, but there's no call to it. However, if I change the value, I got to redeploy my Lambdas, all right? If I do it in my code, you add a pinch of latency to make that call. Again, very small milliseconds, but you can change that value, and the next invoke will grab the value. All right? So, again, secret way to handle that, is parameter store. That's what we generally advise. All right, so the last thing I'm going to show you, and then I'm going to turn it over to Salesforce here, is a new thing we came out with about 3 weeks ago, which is the Create Application Experience. All right, it's just kind of a feature in Lambda. If you do not have a CI/CD and you want one for a simple app you're doing, if you go into Lambda, you go into the Applications tab, and you click on the big orange button that says Create Application. And it's going to give you, all right, what language do you want? What templates do you want? Okay? And it could be like a hello world. It could be an API. It could be an S3. Then what it's going to do is it's going to create the infrastructure as code as a SAM template. It's going to create a repository, and you can tell it I want code commit or GitHub. It's going to create a repository for it. It's going to create a full CI/CD pipeline that's triggered from that repository. Right? So I go in, I create this, then at my desktop, I can do git clone, I can grab it down, I can edit it all I want, I commit, I push, and boom, it kicks off my build steps. And then I have build steps that show right inside my Lambda stage that shows all the steps I have. Something to play around with, something to kind of get your hands on a CI/CD, see how that works. So I encourage you to take a look at that. So for the next part of our session here, I'm going to turn it over to Salesforce. I encourage you to listen to their story. They've got some cool things that they're doing where they're dealing with some of the things that it's not always, it's all serverless and we just throw it in there. So they're dealing with some other things. They're going to talk about their pipeline, how they deploy it, and some tricks they've worked out. So this is Ben and San Yogita, and I turn it over to you, sir.
Awesome.
Don't drink my soda.
I'll try not to.
Thank you.
Great. Thank you, everyone. Really excited to speak to everyone today and talk about our journey through CI/CD and some of the use cases that we were trying to solve in the process. So for a while, our CI/CD process relied on, say, Dave for our application and maybe Christian for our infrastructure. And we knew that we might need to address that when we had a single name or single points of failure, or just a couple points of failure for getting our code out, critical code. Within Salesforce, we're a part of a cloud called Commerce Cloud. Many of you might be familiar with our sales or service clouds. So Commerce Cloud, we provide a e-commerce platform for many large enterprise customers. Some you might be familiar with might be Adidas, L'Oreal. We have over 500 different customers that we support. And in order to support those customers, we provide different monitoring services, different insights to how our platform is performing, if everybody is able to get what they want during, say, a Black Friday or Cyber Monday sale, which was very exciting this last weekend. It's one of our most exciting times. And it also makes that message surrounding serverless really powerful, because in our first-party infrastructure, you start to pay for infrastructure pretty much throughout the year, but you really need to scale up only during those really peak times, such as Black Friday, Cyber Monday. And so at the end of the day, we take in a lot of different insights to our application in the form of metrics, logs, different events. And we leverage Lambdas very heavily in order to transform that data, send it out into our platform so that our customers can view it, send it out to other parts of our organization so that groups such as performance or security can be enabled. So we found Lambda and Serverless to be a great fit for this. So we've been working in AWS since about 2014. We take in about 30 million metrics, time series metrics per minute. We have a large number of alerts to indicate the health of our platform. And we have about 25 different serverless applications spanning over both Lambdas and Fargate. So some of the things that we were looking to solve when we were approaching our CI/CD process, we were looking for a hybrid approach, or at the end of the day, we have a heterogeneous infrastructure where we have both Kubernetes and serverless. Some applications we got a lot of traction out of going full serverless. Some applications, especially those where we were managing state, we found a better fit in Kubernetes. So at the end of the day, we wanted to be able to support that fully featured development environment so that when a developer was deploying into Kubernetes or into the serverless space, that all of that support would be in one well-defined pipeline, and really in a way that developers are familiar with, so that when you push code, that your code goes out. When you have a pull request or a PR, that's a trigger for your code to get moved into stage, go through automated testing, and then deployed directly into production. Another thing that we were trying to solve in this process was ensure that everything was in code, from our infrastructure to our configuration to our application. And so when we were working on this, we started with a lot of the building blocks that you just heard about. And we got a lot of traction now of using these with a small team to leverage them. Next, we deploy into two different spaces. So if you have containers, then you need to build your artifacts in ECR. If you're dealing with Lambdas, then you go and deploy your artifacts and build those artifacts into S3. And then everything rolls up into CloudFormation for us. Nothing against Terraform. You can absolutely use Terraform if that's what your developers feel most comfortable with. And then finally, we deploy into these different environments. And from here, I'm going to let Sanjagita talk a lot more about our serverless pipeline and go really deep into how we support our Lambdas in those use cases.
Thank you, Ben. So let's take a look at our serverless pipeline. So this one has 4 main stages: source, pre-build, build, and deploy. Source stage is self-explanatory. We pull the code from source repository. As a part of pre-build stage, we create an S3 bucket with the commit hash as a name. So the idea here is that for all the build artifacts created for that commit, they should go to the same S3 bucket. Let's take a look at the build step. Now for the build step, we have 2 sub-phases, one where we build infrastructure as a code and one where we build application as a code. So for infrastructure as a code, because we are talking about Lambdas, we have SAM templates, one for each Lambda. So they get injected with environment-specific configuration. Apart from that, we also have some common templates like CloudWatch alarms, which track metrics like Lambda invocations or Lambda errors. So they get injected with Lambda-specific configurations. So now we have a bunch of SAM templates and a bunch of common templates. So as a part of this build step, we combine all of them together and create a one big infrastructure template, which we ultimately deploy. On the other side, for the application code, we have some Lambdas which are written in Java, some which are written in Python, some which are written in JavaScript. Each of them, they have their own build.gradle files, which essentially tell how a build artifact for this Lambda should be created. And they run in separate code build projects. So for every Lambda, we create a different build artifact. So as a end of this build stage, we have this giant infrastructure template and one build artifact per Lambda. So we take all of that and we give it to CloudFormation. As a part of deploy stage, we don't have a lot of customization. It's mostly the CloudFormation doing the job of deploying. So now let's take a look at the repository which feeds this pipeline. If you look at the repo, each folder in this repository is a self-contained Lambda function. So what I mean by that is that it has its own SAM template, it has its own application code, it has its own build.gradle file, which will dictate how to create a build artifact, and it has its own configurations, which are shown in the env.gradle files. So this way, we are able to maintain multiple Lambda functions in a single repository. There's also one thing to highlight here is the common templates. So common templates also live in the same repository, and as we already discussed, they get injected with the Lambda-specific configurations when we are actually doing the build. This avoids a lot of duplication of the boilerplate code and brings a certain discipline in your deployment because your Lambdas automatically come with those CloudWatch alarms. Now let's take a look at the SAM template. Here, I don't have much to highlight. One important thing I would like to highlight here is the commit hash part in the code URI. This is how we try to make sure that for every commit, we create a new build artifact so that we know that when this commit was pushed, exactly what was deployed. This also helps when you are trying to roll back, because at that time also you want to know that when we rolled back, what was the code that was deployed if you're supporting 25 different Lambda functions. Now let's take a look at some of the best practices. I'm not going to cover all of them because Eric and Ben has already talked about some of them. One important thing to highlight here is time to production is a very important metric to track if you're developing CI/CD for your teams. The faster your developers can deploy the changes, the faster they can work on more changes, and the faster they can roll back. So it is a very important metric to consider if you're developing CI/CD for your teams. CloudWatch will provide you with a lot of tools like X-Ray or CloudWatch Matrix or CloudWatch Logs. Do take advantage of them. We heavily rely on CloudWatch Matrix to understand if our Lambdas are doing well, when we deploy the new code. But they also provide you finer control on the resource limits. So we have had incident early this year when one of our Lambda, it went rogue and it spawned 1,000 instances in one account and took the entire account down because all the network interfaces were exhausted. So that's when we came to know that we could set the concurrency limits on the Lambda to make sure that even if the traffic bursts come, only the specified instances are spawned. So these are the type of things you should take advantage of. They are very, very helpful when you are dealing in the serverless world. Creating common code packages is kind of a known practice in the application code area, but do take advantage of it for your infrastructure templates as well. It helps to reduce a lot of boilerplate code, and it will reduce a lot of burden on your developers. So that is something to be mindful about. Last but not the least, developers are lazy. And I'm a developer. So if you are going to tell me to go and delete 10 things, I'm not going to do that. I'm going to forget. So it is important that if you give me one command which deletes all the resources in a clean manner, I'll happily run it. Or if you automate it for me, I'll be very happy. So for lazy folks like myself, I would suggest that you think about building deletion automation in your CI/CD. Or more in general, I would say try to automate commonly used workflows as a part of your CI/CD. That will help your developers immensely. Let's take a look at some of the pitfalls which we learned when we were working on AWS technologies. CloudFormation updates can be hard if you're dealing with the stateful resources or if you're dealing with resources like network load balancers. You may not be able to update them without causing a downtime. So that is something you should be mindful about if they are a part of your deployment. One other important thing to highlight here is that when new features come in for different AWS services, they may not have a CloudFormation support right away. So if you are entirely dependent on the CloudFormation, that may hinder your ability to adopt new features. They get added eventually, but that may delay your feature adoption. So that's something you may want to think about. And with that, I'm going to give it back to Eric. Thank you.
All right, thank you, Ben and Sanagita. Thank you. So we talked a lot about CI/CD today. Talked about how to do it, or talked about what's possible. We didn't give a lot of like exactly, here's the actual code, here's the technical. But I wanted you to see what tools are available and what are some of the best practices. I encourage you, like I said, I have a session I have to go teach in just a little bit, so you might see me buzz out. But my Twitter is EDJGeek, as in Eric Daniel Johnson Geek. Feel free to hit me. I answer questions all the time. I love to do that. I'm a serverless nerd. I think y'all are going to answer some questions if you need to. Yep. We appreciate your time. I really encourage you to fill out the survey. We almost just threw that clicker. Sorry, guys. We really like to know how can we do it better. With that, I thank you. I hope you guys have a great rest of your reInvent. Have a good day.